Hello students, welcome to Spectra Education Academy. In this video, I am going to explain numericals in the chapter current electricity. The first question is, a wire of resistance 4R is bent in the form of a circle. What is the effective resistance between the ends of the diameter? So you can understand the answer first by drawing a circle. Yeah, 4R is the total resistance before you bend. Okay, so here current enters and current splits. Yeah. And so this will be 2R. This will also be 2R. So now both 2R and 2R are parallel. So get back the formula RP 1 by R, R1 plus 1 by R2. So you treat this is R1, this is R2. So therefore 1 by 2R plus 1 by 2R. So LCM is 2R and 1 plus 1 here. So therefore this is 2 by 2R, 2 and 2 get cancelled. So R parallel is equal to R. Moving to the next question. Three identical resistors are connected in parallel. The total resistance of the circuit is R by 3. So make it this is 1 by 3 instead of R by 3. Find the value of each resistance. Right. So three resistors in parallel. So you can understand that once again RP 1 by RP is equal to that to identical. 1 by R1 basic formula is this R2 1 by R3. Then here they mentioned identical. So therefore altogether 1 by R plus 1 by R plus 1 by R. Identical means all resistors are equal. So therefore this is R, this is 3. So they mentioned RP as 1 by 3. RP as 1 by 3. Just substitute here. It is 1 by 3 is equal to 3 by R. Then so this 3 will go up. 3 is equal to 3 by R and R is equal to 1 ohm. So the value of individual resistance is 1 ohm. Moving to the next question. This is the solution of question number 2. Moving to question number 3. A battery of EMF 10 volts and internal resistance 3 ohm are connected to a resistor capital R. The current in the circuit is 0.5 amperes. Calculate the value of current. So you can understand that this is external resistor. This is the battery with some internal resistance. And there is a flow of current 0.5 amperes here. Then you need to find out R. So the EMF of the battery 10 volts along with internal resistance 3 ohm. So when external resistance is connected to the battery, then the circuit is called closed. So in the closed circuit, the potential difference between the terminals of the battery is EMF minus IR. So make it as I into R according to Ohm's law. R. So therefore get this term left side. Take out common I. R plus R is equal to EMF. I is given 0.5 amperes. R value you are looking for. Internal resistance 3 ohm is equal to, this is 10 volts. Cancelling point, you will get here 100. 5 into 20 times. Therefore, R plus 3 is equal to 20. The value of external resistance connected is equal to 17 ohm. Moving to the next question. If the balancing point in a meter bridge. From the left is 60 centimeters. Compare the resistances in left and right gaps of the meter bridge. So get back the meter bridge condition. X by Y, the ratio of the resistances connected in the left and right gap, L1 by L2. So once you notice L1, you can write L2 as 100 minus L1. So they are asking us to find out X by Y ratio. L1 is 60 centimeters. You don't need to convert centimeter into meters. So 100 minus 60. So therefore, this is going to be 60 by 100 minus 60 is 40. 0, 0 cancel. This is 3 by 2. The answer is X by Y is equal to 3 by 2. Next, moving to the next question. This is 4th, 5th. Yeah. But I think this is repeated. The wire of resistance 4R. This is repeated. Question number, I think 1 and 5 same. Next, moving to the next question. Question number 6. The potentiometer wire of 5 meters long and a potential difference of 6 volts is maintained between the ends. So therefore, across the total length, the potential difference maintained is 6 volts. Find the EMF of the cell, which balances against a length of 180 centimeters of the potentiometer wire. So get back the principle of potentiometer. Potential difference between any 2 points is directly proportional to length between those 2 points. So from this, what you can write is potential across the length. Potential across the length is also directly proportional to total length. So therefore, this is the first case. This is the second case. So therefore, V1 first case by second case. V1 by V2 is equal to L1 by L2 is nothing but total length. Then, so V1 is you are looking for V2. V2 is 6 volts across the total length. L1 is 180 centimeters. 180 centimeters means you can convert into meters because this is 6 meters, 5 meters. Sorry, this is not 6. This is 5 meters. 180 centimeters means minus 2 meters. And okay, so this is not 6 volts. This is. So we are looking for total length is 5 meters. Therefore, you can cancel V1 by second case is 6 volts. 180 into 10 to the power of minus 2 divided by 5. So 5 almost 36 times is 180. 6 into 36 is 216. 216 into 10 to the power of minus 2. The answer is 2.16 volts. Moving to the solution of the next question. Question number 7. Battery of 2.5 volts and internal resistance small r connected in series with a resistor of 45 ohm through an ammeter of resistance 1 ohm. The ammeter reads a current of 50 milliamperes. Calculate the internal resistance. So get back the formula. EMF is equal to I into capital R. So capital R is 45 ohm. Then internal resistance. Internal resistance is small r. Okay, so this is ammeter resistance small r. Yeah, internal resistance small r and ammeter resistance 1 ohm. You call it as this is R1. Therefore, in the question, EMF is 2.5 volts. I is 50 milliamperes. minus 3 amperes. Capital R is 45. Internal ammeter resistance is 1 ohm, and internal resistance is R. Ammeter resistance is 1 ohm. So this is going to be 2.5 divided by 10 to the power of minus 3 is equal to 50 into 45 plus 146 plus R. So you can make this is 2500 plus 1000 get multiplied with 2.5. 2500 is equal to 50. 46 plus R. Then 50 into 50. Therefore, 50 minus 46 is equal to R. Then the internal resistance is equal to 4 ohm. Moving to the answer for the next question, question number 8. Two resistors of resistance 10 ohm and 15 ohm are connected in parallel. Find the effective resistance of their combination. So once again, RB, 1 by RP is equal to 1 by R1 plus 1 by R2. Then we are looking for RP, 1 by 10 ohm plus 1 by 15 ohm. So therefore LCM will be 30. 3 plus 2. Therefore RP is equal to 30 by 5. So 6 times. So 6 ohm is the effective resistance. And question number 9. 3 resistors, each of resistance 10 ohm are connected in parallel. Calculate the effective resistance of the combination. So therefore, once again, same formula. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. But they mentioned all are 10 only. So 1 by Rp is equal to 1 by 10 plus 1 by 10 plus 1 by 10. LCM is 10. So 1 plus 1 plus 1. So therefore, Rp is equal to 10 by 3 ohm. So don't forget to mention the unit. Question number 10. In the potentiometer arrangement, a cell of 1.5 volts gives a balancing point at 35 centimeters length of the wire. If the cell is replaced by another cell and the balance point shifting to 63 centimeters, what is the EMF of the second cell? So question number 10. To get back the principle of potentiometer, potential difference between any 2 points is directly proportional to length between those 2 points. So therefore, V1 by V2 is equal to L1 by L2. So as per the question, what is V1 1.25? We are looking for V2. L1 is 35. L2 is 63. So just you multiply 1.25 with 63 divided by 35. So almost you can cancel with 7, 7 5s, 7 9s. Then next this is going to be roughly 2.5. Not 2.5. It is make it 125 if possible with the 10 to the power of minus 2. So 5 into 25 times. So 25 9s are 225 with the 10 to the power of minus 2. So the answer is 2.25. 2.25 volts. Yeah, moving to the numericals of the next chapter, that is electromagnetic induction. The first question is, current in the circuit falls from 5 amperes to 0 amperes in 0.1 seconds. If an average EMF 200 volts is induced, give an estimate of self-inductance. So get back the formula. EMF produced. So L di by dt. So as per the question, EMF is given 200 volts. You're looking for L value. Then you can write this is I2 minus I1 divided by dt. So therefore, 200 is equal to minus L. I2 is 0 amperes. I1 is 5 amperes. divided by time is 0.1 second. So therefore, you can directly multiply the 0 and point get cancelled. This is 20, and this is going to be 20 is equal to the minus 5 into L. So therefore 5L. Then this is 4. So therefore L is 4 Henry. Don't forget to write the unit. And question number 2 is repeated. 5 amperes to 0 amperes in 0.1 second. An average EMF. Same question. Yeah, same solution. Moving to the next question. A pair of adjacent coils has a mutual inductance 1.5 Henry. Yeah. If the current in one coil changes from 0 to 20 amperes in 0.5 seconds, what is the change in flux linkage? Yeah. Flux linkage with the other coil. So question is EMF only. Get back the formula EMF when mutual inductance is taken. So M di by dt. So EMF is the question. M is 1.5 di. So it is nothing but I2 minus I1 divided by dt. So therefore minus 1.5. I2 is 20. I1 is 0. So 0 turned as 20 within 0.5 seconds. Point cancel. This is 3 times. The answer is minus 60. Minus 60 EMF means volts. So moving to the next chapter, that is nuclei. First question. The half-life of radium is 1600 years. How much time does the 1 gram of radium takes to reduce 0.125 grams? So get back the formula. Total time taken for n disintegrations. Every disintegration takes place within half-life period. So the total time you are looking for. Before that, you need to find out n. So therefore, the number of nuclei left with the original number of nuclei put to the power of n. So now the present, the nuclei left over is 0.125 grams. So now n is 0.125 divided by n naught. So how much is n naught? 1 gram. This is equal to 1 by 2 to the power of n. So 0.125 means if you cancel point, you will get 1000 here. This is equal to 1 by 2 to the power of n, and 125 8 times. So therefore, 1 by 8 is equal to 1 by 2 to the power of n. So this can also be written as 1 by 2 cube is equal to 1 by 2 to the power of n, and n is equal to 3. Okay, so once you get n, just go back. They're asking us to find out total time. So therefore, n is equal to 3. Half-life is 1600 years. If you multiply 1600 with 3, 4800 years. This is the answer. Next. Moving to the, if 1 microgram of uranium-92-235 is completely destroyed in atom bomb, how much energy will be released? So get back the Einstein equation. E is equal to mc square. This is question number 2. M is 1 microgram. So 1 micro means micro is 10 to the power of minus 6. Then C is speed of light, that is 3 into 10 to the power of 8 whole square. So therefore, 10 to the power of minus 6, and that to gram they mentioned. This is a micro. So one more 10 to the power of minus 3 will come, converting into kg. So therefore, 10 to the power of minus 6 with 10 to the power of minus 3, and 3 into, this is after you multiply 3 into 10 to the power of 8 with 3 into 10 to the power of 8, 9 into 10 to the power of 16. This is minus 9 plus 16. So therefore plus 7. So the answer is 9 into 10 to the power of 7 joule. So moving to the next question. Calculate the energy equivalent of 1 gram of substance. Same formula. E is equal to mc square. So 1 gram directly given 10 to the power of minus 3. C is as usual 3 into 10 to the power of 8 whole square. So 10 to the power of minus 3 with 9 into 10 to the power of 16. So this is going to be 13. So the answer is 9 into 10 to the power of 13 joule. So in my next video, I'll continue with the explanation of long answers. So in the chapters waves, current electricity and nuclei. Thank you very much for watching my video. Don't forget to share and subscribe with your friends and relatives.